Well, today we're going to add more characteristics to our functions. Today we're going to focus primarily on domain and range. But let's first start with a warm-up. Verizon charges $15 a month plus $2 per app downloaded. I said in class to be mindful of what the per or each tell you, because that tells you what the input is. The input for this would be the number of apps, where the output in this case wouldn't be months, but it would be a dollar amount, your total bill. When you look at the input and the output, determine whether or not they're discrete or continuous. In this case, the number of apps is discrete. I can't sell you a half of an app, okay? That wouldn't make sense. So then that means the function is discrete. This is also linear, and the function notation would be, with the starting amount of $15, I am adding $2 each time. So today we're going to look at domain and range. One of the key things to remember, though, is ask the question of the function, is it discrete or continuous first? Because if it is discrete, there is a way to write the domain and range. And if it is continuous, there is another way to write the domain and range. As a reminder, domains are x values, where ranges are y values. So when I look at this set of ordered pairs, the x values are your domain. So the domain for this would be -11, 4, 3, and -5. Where the range would be the y values of 2, 5, and 10. Again, last semester we used set notation. And I will tell you that set notation is how you will list the domain and the range of discrete functions. As a reminder, discrete functions, you don't connect the dots, but in continuous functions you do, and on the line there may be dots that are apparent. That still means that it is continuous. The line or the dots are connected. Taking a look at this discrete function, which is already graphed for you, I want to know what the domain is. As a reminder, the domain are the x values. So one method would be to write down all of the coordinates for these dots. So 0, 2, 2, 4, 4, 6, 6, 8, and 8, 10. The domain would be all of the x values for those sets of dots. So the x values are 0, 2, 4, 6, 8. The range would be all of the y values. So in that case, it would be 2, 4, 6, 8, and 10. Now, domain values are the values in order from left to right. So remember that domains are read from left to right. The range values are in order, but they go from bottom to top. So remember, range values are found from bottom to top. This graph is linear. Looking at this graph, we can answer the question of it being linear or exponential. Because of the curve, it is exponential. Our ordered pairs for this one would be 0, 8. This looks like 1, 4. That's 2, 2, 3, 1. And then finally 4 and 1/2. The ordered pairs for each of those dots. My domain then would be from left to right, 0, 1, 2, 3, and 4. And the range would be from bottom to top. So 1/2, 1, 2, 4, and 8. Sometimes we provide you with the graph of a word problem, as we did in this case, and then sometimes we do not, which is on this one that will follow. On the first one, Taking a look at the graph, we notice that the input values, if I were to write the ordered pairs for each of these dots, would be a domain of 0, 1, 2, all the way up to 10. Why to 10? Well, when we look at the word problem tells us that the input, remember on yesterday's notes, the input is number of candles, and we have a total of 10 candles. The output is the range. The range would be the dollar amount. Notice that my scale goes by 2.5 or $2.50. So 0, $2.50, $5, ... all the way up to an amount of $25. Now we kind of knew that without using the graph, because if I read the word problem, I notice that the input is the number of candles, and then the output is $2.50 for each candle. So starting with 0 sold would be $0, 1 sold would be $2.50, 2 sold would be $5, etc., as we get up to $25. On this example, we don't have the graph, but prior to this, or looking at this from yesterday's standpoint, we had the input of number of ice creams. So my domain, the input, would be 0 up to 6. 3, 4, 5, and 6. And the output for this one would be the dollar amount. And it would be $0, $1.50, $3, all the way up to $9. Now another way of doing this would be from yesterday's notes. We found that the function notation was f of x is equal to $1.50x. So you could, in order to find the range, simply take the domain values and plug them in. Plug in a 0, you get 0. Plug in a 1, you get $1.50. Plug in a 2, etc. When there is no ending, the range or the domain has no end. In this case, same word problem, but we left off the fact that there were 6 ice creams to sell. So in this case, there are infinitely many. Then in the discrete notation, we would do 0, 1, 2, and then ... Okay, to say that it continues. The range would be 0, $1.50, $3, ... Now, continuous functions. On continuous functions, we use inequality notation. So if you notice, this x value is at -6, and the ending x value is at 2. All of the domain for this continuous function would be between the values of -6 and 2. Same for the range. Remember, range is from bottom to top. So the bottom of this is at -7, and the top of this is at 9. So then my range would be from -7 to 9. Also, if you will notice, in the middle of these inequalities notations, the compound inequality notations, we have an x for domain, but a y for range. Be careful of that, because some students do find difficulty in remembering where the x or y should be in the notation. So here's my first example. My method to solve these is to first notice that there are closed circles at each end. So that means my domain will be less than or equal to x less than or equal to. I just put that. Then I look for the x values and place those in. The range, the same. I notice closed circles, so it's a less than or equal to y less than or equal to. And it goes from 2 up to 4. I notice an open circle on this end. So my domain will be x less than or equal to x less than. It's still the 0 and 8. But notice this one does not have the equal to. And the range for this one, same. I notice an open circle at that end, bottom to top. The bottom circle is closed. So less than or equal to y less than. And it goes from that 2 to 4. Sometimes we have an arrow. Now on this problem, let me move my strange looking mug there. Okay. But in this one, we have an arrow at both ends. And in order to indicate what it is with these arrows, we use something called an ellipsis to use that. Now domain, again, I will put the fact that this x is between the less than symbols. But because I don't know where it actually starts, I will use negative infinity for the negative side of the x's. And then a positive infinity to show that it goes through all of the x's. For the range, similar. At the bottom here is negative infinity, and the top here is positive infinity. If you notice, this arrow says I don't know where it actually starts at the bottom. So my range will be from negative infinity less than y less than infinity. When you have two arrows, you may want to just ingrain this into your mind. When you have two arrows, then you're going to have two infinity symbols for both the domain and for the range. Because on this next one, with a closed dot here, and an arrow there, when I have one arrow, that tells me there's going to be one infinity symbol. So the domain is the less than, x less than. It starts at 0 and it is equal to that, but then it goes through infinity. Remember, this is the x values, so to infinity. Reading from left to right, left to right. The range is bottom to top, so we have a less than y less than. And the range is a closed circle at 1 for the y value. And then it keeps going up to positive infinity. So there's my range. You should see a closed dot here, arrow there. That tells me there's going to be one infinity symbol as a part of this. Okay, so the domain less than x less than. And the domain in this case goes from 0. And then it just keeps going towards infinity. The range, on the other hand, and this is a tricky one, but the range will be from the bottom of the graph to the top. Notice the bottom here is at y being 0. And then the top is at 8. A very tricky situation. Okay, so it doesn't go down here to negative infinity for the range. It stops here at y being 0. And we're going to talk a little bit about that when we get into the asymptote. Typically on the exponential functions, the asymptote comes into play as a part of the minimum or the maximum. All right, so domain and range on continuous graphs. Taking a look at this one, you got to decide whether or not to connect the dots. We do connect the dots in this one because the time is continuous, the distance is continuous, so this is a continuous function. Be careful then, that means don't use the set notation. What we're going to use is the inequality notation for domain and range. So the domain would be from 0, and then domains are 10, 20, 30, 40, all the way up to 80. The range, in this case, would be from 1 all the way up to 8. 0, excuse me, from 0 to 8. You had a homework sheet, so make sure you get that homework done. And we get into more characteristics starting tomorrow.